It's Mr. 13 Things coming at you again with a relative rapid turnaround Khan Academy Homebrew, I guess I'll call it for now. See a little HR there? That's me. Next time you see it, it'll be a little bit better laid out. In other words, this is an exercise that is not submitted out to Khan Academy. It's something, however, that I'm trying to mimic what a classroom teacher could very quickly do. And then hopefully build up a library internal to an organization and shared through some winnowing or jurying exercise. So this is based on my own kids' class, 7th grade, in the quote-unquote accelerated, whatever that means. And the problem statement for the quiz today was learning just basically the squares from 1 to 20. Now, I learned 1 to 12. I'm okay with 13. 15 I got. All the way up to 20 I'm a little bit clueless. But my daughter had it pretty well sussed, so I don't have a problem with that. But the problem there, learning squares, realistically, you're learning squares so you recognize square roots. I see the intention there. Obviously, many of us in engineering understand 25 squared. I don't know why, but we do. 15 squared, 225, 25 squared, 625, 30 squared, 900, up the ladder. And of course, they don't come in engineering as 15 squared. They come as 1.5 squared. And they don't come as 25 squared, they come as 2.5 squared. And so learning to see and recognize things is what Donald was all about walking through the forest. So if you haven't looked at Donald Duck in Mathmagical Land out on YouTube, please do. Our kids' futures means that they're all going to need to be creative, and Donald Duck and Walt Disney were nothing if not creative. All right, that said, so here's what the exercise looks like. It's called perfect squares. I guess it should be called perfect square roots, but I can change that around. And you start with basically some general statement, hopefully that ties students into why you're learning it. Learning squares will help you to really appreciate square roots, just like Donald Duck in the forest. Eventually, that would be great to have a little HTML link there. But you'll see Khan Academy does have an ability to link you out to videos if you don't do well on an exercise. And you notice there, what is the value of the square root of 178 minus 57? Right away, after you go to the rote, you've got to start getting students to realize that these things will be buried. So a lot of what simplifying is about is finding the pearl inside the clam. So, and I don't know the answer. I don't have a calculator, so we're going to go to I'd like a hint. It turns out that the square root of 178 minus the square root of 57 is the same as the square root of 121, and that I know. Now, many of you have to realize as you go through here, the answer to the square root of 121 is actually plus or minus 11. And in this case, this is not going to give you that. It implies when you have the square root of 121, it is you are asking for the principal root. But if we go with the concept that 4D in 4th grade, perhaps we should really be getting these answers plus and minus, and that's the kind of set of different levels of hints you might want to give. That's not set up that way. I will add it to these, however, as knowing that the square root of 121 is either minus or plus 11. But let's look at the next hint, and the square root of 121 is 11. And I've added an extra hint. Usually that would be the 11 there would be highlighted because that's the answer you're looking for, and I'd like another hint. But Donald knows that in the forest you will just as often encounter the square root of 133, which is not a perfect square. The only perfect squares are your parents and teachers. Okay, so there's some generation even within the hints there. You notice that you might have something equally lame as the final bit there. So trying to keep it light as much as you can in the practice area. We now are going to check our answer. I'll go ahead and put in first 13. That's wrong. I'll put in 11, and you see each time that data being sent out to some server. Okay. Okay, that's what it looks like. Now let's look at what the HTML code looks like, built in the exercise, the Fine MIT license exercise generator in the Khan Academy. And once again, knowing a little JavaScript will help, but it's not a great necessity. Most of this is pro forma. You have the title, you get to here. This is in fact where some variable declarations were made. The second variable here is not necessary. What it did is it grabbed a random number between 10 and 20. In other words, I was not testing the perfect squares. This number could be changed later if you wanted to go to perfect squares above 20. I don't know why, perhaps for competitions. Later on, you'll see building up perfect squares that are something like 25 and 30 might be more useful than building up individual numbers. You have another one there, and I'm going to point out now the first time this data ensure statement. So I really added this second variable here. It isn't necessary, but I put it in there because I was doing some troubleshooting, and what I'm going to do here is I'm going to add a data ensure statement that says that I'm going to make a variable called subtract number, basically. I want it to be less than the square of the number that I chose, and I want that number to be random between 1 and 300, but it must be, according to this, less than the square, because I don't want to get into square roots of negative numbers yet. That would, of course, would be later in 4th grade. True belief, we'll see whether it ever pans out, but in fact, if our kids are doing gaming in 3 dimensions and 4 dimensions, by the time they're 2nd or 3rd grade, then they should probably be looking at complex numbers. Their brains are a little bit more capable than we think of, at least those that are playing games. That said, I now go down. You notice in the next statement here, you've got the problem statement, that kind of idea, explaining what's going on. And then this is the next part where you start to have a little bit more of this coding. What is the value of? And then there's some playing around and learning you need to do here. But basically, this is using MathJax or LaTeX for getting proper mathematical syntax, I guess, or symbolage. It puts it in there, and then it gives you this important here is the solution. So that's the number, the answer that it's looking for, and then a lot of the value in all of this is tied up in the hints. So the first time through, perhaps you might want to just go ahead and just not put any hints if you're trying to crunch some things out, but perhaps have the students develop the hints and then you build it with the coding in later. So very quick turnaround. I made this a little bit more complex than the simple drill and kill, which would be what is the square of 15, or what is the square root of 225, what is the square root of 121. But you have in this now something that you can actually have the kids drill and monitor, and you have some ownership. And that's what I think part of what may be missing here when I look at some of the resistance to adoption. It's this pull between teachers giving up. They don't want to give everything up because they don't want to be out of a job. On the other hand, they don't have time to build a lot of these. However, if they build them in community and share them, then you can quickly build a very large library. And it's built in open source, right? I don't care if I'm in Rapids or Stevens Point or wherever. You've got to be looking at, as much as you can as an organization, at being able to link up across cities, counties, states, and nations for some of this work, and it not always being proprietary, except if you're Disney. So if you haven't been out to YouTube to see Donald Duck and Magical Land, you're going to miss a lot of the point as I go forward, but hopefully this will help you out, and thanks for listening. This is Mr. 13 Things.